In your chart, you should have used rate, times, and distance. For the car, you should have put 60 for the distance, and for the plane, you should have put 340 for the distance. It said the same time, so you should have used the exact same letters. And the rate, well, we don't know the rate of the car, so we can just call it R. The plane, it said it was 40 faster, so you use plus 40, then 5 times the rate of the car, so 5R plus 40. We'll make two separate equations. This one will be R times T equals 60, because you just go straight across. This one will be 5R plus 40 times T equals 340. Since we want to figure out the speed of the plane, which is a rate, we want to isolate T. So we're going to do T equals 60 divided by R. And over here we're going to do T equals 340 divided by 5R plus 40. Since we have two equations that both equal T, we set them both equal one to another. So we do 60 over R equals 340 over 5R plus 40. You find your common denominator, which is R and 5R plus 40, and you figure out what's missing. This R cancels, and you need a 5R plus 40 on the left. This 5R plus 40 cancels, and you need an R on the right. Continuing to solve, on this side you get 60 times 5R plus 40, and on this side you get equals 340R. Distribute in, you get 300R plus 2400 equals 340R. Continue to solve by bringing the R's together on the same side and dividing by 40. You'll get 60 equals R. Once you do that, you need to go back to your chart and figure out what that means. This R is the rate of the car. What they want us to do is find the rate of the plane. So we'll say, therefore, the plane goes 5R plus 40, which equals, plug in 60 for R. We'll say the plane goes 5R plus 40, but 60 is R. So the plane goes 340 miles per hour. And it just happened that this time the miles matched up. The numbers just worked out. Please don't assume that will always happen. Example 5. It takes the tub 4 minutes to fill up using only the cold, and it takes 7 minutes running the hot water. How long would it take if they're both turned on? Okay, well, this is a job that's happening, so we use a work chart. Rate, time, work. We have the cold and the hot. Just remember, when you talk about work, you use fractions for your rates. The cold is 1 tub in 4 minutes. The hot is 1 tub in 7 minutes. Remember, T is their time together, so T and T. Their work is when you multiply these two items together. So T over 4 and T over 7. We want this to fill up 1 tub, so we set the cold T over 4 plus the hot T over 7, and we're going to see how fast they can do this together. The common denominator between 4 and 7 is 28. This 4 cancels and it needs a 7. This 7 cancels and it needs a 4. The 1 needs all of the 28. Multiply things together. 7t plus 4t equals 28. 11t equals 28. And t is going to equal, it's going to be a decimal, approximate 2.5 minutes when you divide. So we'll make our therefore statement. It says how long will it take if they're both on. So we're going to say therefore, with both on, the tub will fill in approximately 2.5 minutes. Let's keep going. Example 6. You have 30 gallons. 30 gallons starts as 5%. It's mixed with 40 gallons, and that 40 gallons is at 8.5%. What will the final product be? So I like to draw a picture. It's 30 gallons, and whatever is in there is 5%. 5% of it is salt or sugar or whatever it is. Now we're going to add, it says, 40 gallons. That's an 8.5%. They want to know what will the final percent be of the total. Now you should know that the total here is 70, and we got that because of 30 plus 40. Let's make our equation. Change your percents to 0.05 times 30 plus 0.085 times 40. And you should realize, you see how you're adding more of the stronger one? It's going to be closer to 8.5 once you mix it. Equals 70 times x. So 0.05 times 30 is 1.5 plus 0.085 times 40 is 3.4, and that equals 70x. Add those together to get 4.9 equals 70x. Divide by 70. X is 0.07. Now that is not the percent until you change it. So that is equivalent to 7%. So we make our therefore solution based on what we needed. What will the percent of the final be? We'll say therefore the final mixture will be 7%. Moving on. It takes Bob 3 hours to do his homework. Together, Bob and Riley can get their homework done in 2.7 hours. So you can see it's just a little bit shorter than 3. So obviously, Bob's a lot faster than Riley. Riley doesn't help him out too much. How long will it take Riley all by himself? Here's a question for you. If Bob and Riley, if it took them both 3 hours, you should be able to figure out. Well, think about that, and then if you want to come back and tell me what your answer is, pretend that they both worked at the exact same rate. Why don't you try to figure out how fast it would take them? But they don't. So here we go. This is a work problem. We've got Bob and Riley. Remember, with work problems, you have to use fractions. Bob can complete 1 night of homework in 3 hours. Riley can complete 1 night of homework, and we don't know. It doesn't tell us. Now remember, this is time together. They do give us the time together, and that time together is 2.7. So when we do our work over here, we get 2.7 over 3 for Bob. If you guys want to make that 0.9, you can, but I'm going to leave it just for now. And for Riley, we get 2.7 over x. We want them to be able to complete their homework in one night, or one assignment. Okay? We'll write one night's assignments on there. One night's homework. So we're going to take Bob's work of 2.7 over 3 plus Riley's work of 2.7 over x, get our common denominator. In this case, our common denominator is 3x. And we're going to figure out what's missing. This 3 would cancel, and that would need an x. This x would cancel, and this would need a 3. Nothing here would cancel, and it would need a 3x. Again, the common mistake is that people would keep that as a 1. So our new equation is 2.7x plus 3 times 2.7 is, or excuse me, 3 times 2.7, figure that out. Get me. 8.1 equals 3x. Now what we're going to do is solve for x. So we get 8.1 equals, when you take 2.7 over, you get 0.3x. Divide it out, and you get x equals 27. Now take a look at your chart on where x is. X is Riley by himself. Poor Riley. So we're going to make a therefore statement there. Say, therefore, Riley can finish his homework by himself in 27 hours. So let's hope Riley has a friend. Example 8, last one. It takes 2 hours for me to teach you a concept with no TV turned on. It takes me 8 hours to teach you a lesson if the TV is on. How quickly can the TV make you forget my lesson? Now this is just hypothetical. I know it's not really true, but it makes it a little more fun when you can see different ideas clashing here. This is a work problem, so we do rate times and work. We have no TV, and we have with the TV. Our rate, let's talk about no TV. With no TV, I can teach you one lesson in 2 hours. With the TV, I wrote that I can teach you one lesson in 8 hours. Or excuse me, with the TV turned on. So that's not 1 over 8 at all. With the TV turned on, that's time together. So actually, 8 goes in here, because that's with both of them working. So with the TV on is 8 hours, that goes in the middle, because it actually says how quickly does the TV work. So our x goes under the TV. Now, something I'm going to do here is I'm going to put a -1 on the top. The reason for the negative is because the TV makes you forget. Or maybe we could say it works against you. So anytime you have any type of problem where something's working against something else, you're going to use a negative. Okay, so that's why we use that negative there. So with no TV, I get 8 over 2, which you guys should know that just really is a 4, right? 8 over 2 is 4. With the TV is 8 over x. Now we're going to try to figure out how quickly the TV works. And in fact, this is a -8 over x. So our equation will be, start with the TV. We do, without the TV is 4. This time it's -8 over x since it's making you forget. And that will equal 1 lesson. Your common denominator is an x. So now you need to figure out what's missing. This is over nothing, so it would need an x. That's good. And this would need an x. So you get 4x minus 8 equals x. Subtract x, you get 3x. Add 8, you get 8. Divide by 3. X is approximately 2.7 hours. So here's our therefore statement. We see therefore the TV makes you forget a lesson in 2.7 hours. Now, while this may be not like an exactly true problem, you get the idea that you're going to use this example if things are working against each other. Okay? An example, maybe a more real example would be like if you have a leaky sink. Okay? If you have a leaky sink, those are things that are working together. Like if you turn the faucet on and it's dripping out, that would be a negative problem. Okay, so anytime that you have two things working against each other, you're going to have to use a negative.